In this lecture, hello friends, in this lecture we are going to focus on kutzbach equation. But before that, we understand in brief about degree of freedom. If you want to watch full lecture, you can go through cards or through a link which is below in description. So what is degree of freedom? The minimum number of independent variable required to define the position or the motion of the system is known as degree of freedom. So this is the definition. Degree of freedom we can write 6 minus restraints. What is the meaning of this 6 and from where it is come? Suppose this is x-axis, this is y-axis, and this is s-axis. Suppose this is element, so it can move through along x-axis, along y-axis, and along x-axis, and it can rotate in xy plane, in xz plane, and in xy plane. So it is having 3 translatory motion and 3 rotational motion, total 6 motion. So this is 6. What is the meaning of restraint? Suppose we have a link and two link and be joined through a pin joint, then it cannot translate in any direction because it is restricted on this position. So it cannot move along x-axis, along y-axis, and along z-axis, or it cannot rotate in we can say xy plane, in yz plane. It can rotate along xz plane. So it is only one motion. So number of restriction, that is along x-axis, along y-axis, along x-axis, along xy plane, along xz plane, it can only rotate in along xy plane. So restriction is 5. So degree of freedom of this bill 6 minus 5 is equal to 1. So it is having degree of freedom 1. So this is the meaning of restriction. Suppose if I want to know kutzbach equation, then I can write f is equal to 3 l minus 1 minus 2j minus h. From where it is come? For this be concerned or we focus only in 2 dimensional. In TOM we only discuss about 2 dimensional or in a 2 dimension, that is along x plane and along y-axis plane. If I want to draw the element, then it can go along the x-axis, along y-axis, or it can rotate in xy plane. So it is having 2 translatory motion but plus 1 rotatory motion. So total number of motion now is 3. So this is number of motion is 3. But for a kinematic pair, we fix one link, and suppose we having 2 link. If I fix one link, then only one link can rotate. So this is one link which is I am going to fix is minus what is 2 or j. To make a joint, we required one link, 2 link. To make a one joint, we required 2 link. So this is which is required the number of link to make a joint. So this is 2 and one higher pair. If we are having higher pair, what is the meaning of higher pair? You can watch through a lecture in a previous, as I explained. But meaning of the higher pair then is line contact or point contact, then it is known as higher pair. So this is the equation, that is kutzbach equation. F is equal to 3 l minus 1 minus 2j minus h. So this is the equation of kutzbach, where 3 is total number of motion, 2 translatory, 1 rotately, and we fix one link. So I subtract one link, and to make a joint we require 2 links. So this is 2 and 1 higher pair. So this equation is known as kutzbach equation. From here we derive the kutzbach equation. So this is about the kutzbach equation. If you want to watch the lecture on degree of freedom, you can go through I or link is in description. You can go through there and you can watch. So this is about the kutzbach equation. So thanks for watching. Thank you.